Welcome back to The Explainer. Today, we're diving into a really fascinating attempt to crack one of the toughest codes out there, the stock market. We're looking at some new research that asks if an AI can predict stock prices by doing something, well, something very human, reading the news, and, you guessed it, scrolling through Twitter. So, let's see what they found out. I mean, it's a question that feels incredibly real in our world today, right? Can that constant flood of social media chatter and breaking news actually tell us where a stock is headed? And that's really the heart of the problem here. How do you teach a machine to understand not just the numbers, but the actual story that's driving them? All right, so to really get why this new approach is so exciting, we first have to take a look at the old way of doing things. What was the standard playbook for trying to predict the market? Well, traditional models were basically like driving while only looking in the rearview mirror. Seriously. They're built on historical price data, and they operate on this big assumption that the future is just going to neatly follow the past. But that whole idea kind of falls apart in today's markets, which are, let's be honest, chaotic. They're fast-moving, they're swayed by headlines from all over the world and social media. The old tools, they just can't keep up. So, what's the missing ingredient in that old playbook? It's the story. It's that massive, constantly growing river of text from news reports and social media that's packed with clues about what might happen next.
Now, early attempts to use text just tried to figure out the vibe. Was a tweet positive or negative? But as the researchers point out, that is way too simple. Just focusing on sentiment means you miss the really juicy stuff, the crucial facts and events that are actually described in the text. The real goal isn't just to measure the market's mood, it's to understand its meaning.
And that brings us right to the core challenge. How on earth do you build a system that can process two totally different kinds of information? On one hand, you have the structured, cold, hard numbers of stock prices, and on the other, you have the messy, unstructured, and just enormous world of human language. How do you fuse those together into one single, coherent prediction? This is where the researchers roll out their solution, a new model they call FTS Text MOE. Now, it's designed to be incredibly powerful, but also, and this is key, surprisingly efficient. So how'd they pull that off?
The secret sauce here is a concept called a mixture of experts, or MOE for short. Now, instead of having one single giant AI brain that's trying to know everything about everything, an MOE system is more like a team of specialists.
Just think of it like a team of analysts at a big financial firm. When news about the tech sector comes flooding in, you don't ask your oil and gas expert to analyze it, right? Of course not. A smart manager, or in this case, a little piece of code called a router, sends that task directly to the tech specialist. And while they're working, the rest of the team just chills. They save their energy. This AI model works the exact same way, and it saves a massive amount of computing power. And to give you a sense of the scale we're talking about, the entire model has 113 million parameters. You can think of these as tiny little dials that the AI can tune and adjust as it learns. It's a huge amount of potential knowledge packed in there. But here is the really clever part. Because of that team of specialists design, for any given task, the model only needs to wake up about 50 million of those parameters. It has all that power on call, but it only uses the specific expertise it needs for the job at hand. This is what makes it both incredibly powerful and incredibly fast. Okay, so we've got this powerful, efficient model that can read both numbers and text. The theory sounds great, but the billion-dollar question is still hanging out there. Does it actually work? Let's take a look at the results. The results are, well, they're pretty staggering. When you compare it to other models, and even the S&P 500 index during the same test period, the difference is just stark. Just look at that bottom row. While the others were losing money or barely breaking even, FTS Text MOE pulled in a cumulative return of over 13%. But even more important is that Sharpe ratio. That's what measures your return against the risk you took. A ratio over 1 is considered excellent, and this model hit 1.08. It just blew the others out of the water. So how did it get those amazing returns? Well, the model took on a much more aggressive strategy. Because it was reacting to text in real time, it made bigger, more confident bets. As you can see, its biggest wins were way larger than the other models. But so were its losses. This high-risk, high-reward approach is a direct result of it trading on the news, on new information, not just on old data patterns. This whole thing really points to a new and pretty exciting direction for financial forecasting and, for AI in general. So what does all this mean for the future? The real breakthrough here, the big takeaway, is this fusion of data. By teaching an AI to understand the meaning behind the words, not just the patterns in price charts, we get a much richer, more dynamic picture of the market. It's a huge leap from just processing data to actually achieving a genuine kind of understanding. Of course, it's not a magic crystal ball. The researchers are very upfront about the limitations. First, there's the time lag problem. There's often a delay between when news breaks and when the market fully digests it, and the model doesn't handle that perfectly yet. And second, what about fake news? The model could easily be tricked by misleading or false information. So these are the next big hurdles that need to be cleared. So what we've seen in this explainer is an AI learning to understand the complex, messy, and often chaotic language of finance. That's a huge step, and it leaves us with the final question. If an AI can learn to read the nuance and the facts driving something as complex as the stock market, what other complex human systems will it learn to read and maybe even predict next?